Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 10 of the November till Leetcode challenge, and I guess this is the fourth or the fifth day that we're having questions again revolving around the topic of bit manipulation, and we're going to deal it with a different approach today. Okay, compared to all the approach that we had in the previous 4 or 5 days, this time it will be a different approach. So basically, like from November 4th onwards, I guess we are having questions on bit manipulation. Okay, today we'll see a very different approach compared to what you have seen in previous days. Okay, it is question 3097, shortest subarray with or at least x. Okay, so this is the second part of this question. Okay, so in this particular video I will showing you both the Java and the Python solution, and in the comment section I will also be writing the time to which you can jump if you want to see the solution directly. Okay, for Java and Python both. So let me quickly begin with the description of the question without wasting any of your time. Okay, so basically we'll be given an answer. As you can see, it's an integer array, and we'll be given a k which is 2, right? And in the output we have to return an integer. Okay, let's see what the question is. Yeah, you are given an array nums, okay, of non-negative integers and an integer k, right? An array is called special if the bitwise or of all the elements is at least k. Remember, we are talking about all the elements here, okay, of at least k. Next, what we are seeing, return the length of the shortest special non-empty subarray of nums, or return -1 if no such special subarray exists. Okay, so they are talking about a subarray. Okay, so see, initially they're saying they need all the elements, but here we need to take all the elements of the subarray. Remember, it's not for the whole array. So what they're saying, return the length of the shortest special non-empty subarray of nums, or return -1 if no such array exists. Okay, what we have to do, basically what is special is if the bitwise order of all the elements in that particular subarray is at least k. Okay, remember, at least means it is either greater than or equal to k. So what we have to do here, so basically they're talking about k is 2. Okay, so we'll need to find a subarray, okay, for which k is, remember that subarray can be single element itself. So in this case, if you see, this single element itself is 3, right? Obviously if the number itself is greater than k, then that single element itself will be able to form that particular subarray. So here the length is going to be 1. Okay, this one or this one, either of them, okay, can form a subarray of length greater than k. That is the first thing. Next, here if you see, okay, the k is 10 here. So here if you see, basically we need 2 and 8 to form it. That is, if you do OR of 2 and 8, you're basically going to get 10. Okay, that is the basic idea. But remember, they are not adjacent to each other. That means if you want to take 2 and 8 together, you'll have to take the 1 also. Okay, because it's a subarray. Remember, they're talking about a subarray. Okay, so I hope you understand the difference between a sub and a subsequence. Okay, these two are very important topics, and they are not equivalent. Remember that. You can Google search based. Okay, just for your convenience, you can just Google search to understand the difference between the two. Here we are talking about this sub array. Okay, so here basically you have to include 1 also if you want to include 2 and 8. Okay, that's why the here answer is 3, right? And same is the case here. Okay, here k is 0. So basically you can take any one element, and obviously it will be any non-zero element you can take, and obviously that is going to be the answer here. Okay, so if you see the constraints here, so basically the num size value is going to be up to 10 power 9. Okay, so I have done a calculation to understand how many bits you will require for that. So let me quickly show you that calculation, and then we can start the solution. Okay, so here is the calculation for that. Okay, so 2 power 9 is basically equal to 10 power 9, because try to understand, if we have n bits, so each bit can take 0 and 1. So total number of values that we can store using those n bits is 2 power 9. So 2 power 9 has to be approximately equal to 10 power 9. Okay, so if we try to solve this, we'll get n log 2 is equal to 9. So basically n is equal to approximately 30. Okay, 29 point something it will come. So approximately n equal to 30. That means we need 30 bits to solve this. Remember, even the LeetCode, okay, in its original solution is not considering this. Okay, it is also taking 32 bits. Not correct. Okay, you will have to take this only. Remember, even LeetCode did this mistake in its solution. So kindly avoid this. Okay, they also have done this mistake. But in, if kind of, see, here we are talking about OR operation, right? In case of OR, obviously we'll need this kind of calculations. Okay, in yesterday's question we did not do this, because here they were actually exceeding the limit that is given. Okay, that is a different case. But in this kind of questions, if this comes in a live interview, that is face-to-face interview, you are expected to do this kind of calculation and show how many bits you're going to require. Okay, you cannot simply assume that it is okay, 32 is enough or 31 is enough, like that. Okay, so yeah, by the way, like for Java and like C++, one integer is basically has 4 bytes, which is 0 to 31 bits. Okay, so yeah, that is 32 bits, right? So in this case, 30 will be enough for us. That's what I wanted to show you, right? Next, because this question revolves around the topic of OR, let me quickly show you what OR is. I am assuming you will be knowing this, but since this question is slightly easy, so let me spend some time in explaining you the same. See the approach, as you can see here. Okay, whenever a single bit is 1, the resultant bit will be 1. That is what is OR operation, right? Remember, previously we had questions around AND. I think yesterday we had question around AND, and prior to that we had question around XOR. Okay, so like everything is getting covered here. So today is operation is getting avoided. Okay, so in this, if you see, even if a single bit is 1, the resultant bit is going to be 1. Okay, just for your convenience I'm showing you, but yeah, I'm sure you will be knowing this already. So now coming to the solution. Okay, this from here the Python starts. After that I will be going through the Java solution, right? So what I'm doing, see, I'm going to use the basic, sliding window approach. What is sliding window? See, the idea is very simple here. Okay, for example, yeah, this is the sliding window. I will be, see, slide window will start from 1, then it will keep expanding, keep expanding, keep expanding till the within the elements, if the XOR, okay, that is, sorry, not the XOR, the OR operation. Okay, the window will keep expanding till the elements within the window give a result of k or greater than k. Okay, as simple as that. Once we get it, we will stop there. Then we'll see if we can remove some element. That is, see, what is the first step? First step is expanding the window. Okay, I will be showing everything, but just understand the theory first. First step, expanding the window, under which we will be expanding the end of the window. Okay, so window is initially like this, then it will be like this, like this, like this, it will keep expanding. Okay, we will stop at a place where the the elements inside it are giving or result of k or greater than k, or result of k or greater than k. Okay, we'll stop there. Okay, then we'll try to see whether I can move the first. Now see, my end is at 4, start is at 1. Okay, so what I will do, I will try to move the start now. Okay, so I will select this part now. I have excluded 1, and I will try to see whether still I am getting a or of k or greater than k or not. Okay, if still I am getting, then I will still move the start. So currently start is at 2, right? What I will do, I will move the start to 3 and 4 now. Okay, remember, and is still in its place, but I'm still moving the start. But let us say in this place we realize that no, we are no more getting the result of, you know the or result is not greater than or equal to 4. So that means we cannot get below there. So okay, so we'll stop here, and now we will start expanding the window again. So it was at 3 and 4 now. Okay, now it will be 3, 4 and 5. That is, I am moving the end again. So that is how it will be doing. Okay, so I have explained here how the window will be moving. If you have not understood, pause this video, go back to 5 10 seconds back, again replay it. See, the idea is this only. Okay, this is the only idea, but yeah, you may be finding it difficult to understand the first approach. So yeah, meanwhile, while I'm explaining the solution, I will be again coming back to this, and I will be explaining with the window. Okay, so don't worry about that. So starting the question. So here basically, see, I'm using two variables to control the window size. Okay, sub array start is equal to 0 and sub array end is equal to -1. Okay, why I have kept it -1? Because in my algorithm, basically, whenever I'm entering the while loop, I'm using doing a +1. Okay, so that is the reason why for the first element it has to be 0. So I'm keeping a -1 initially before entering the loop. Okay, that is the reason why you can keep anything based on your code. Okay, there is no such like algorithm for which I'm keeping this like this. Okay, it's not like that. So for based on my code, I'm keeping it as -1. Right? I am recording the length of the nums array is n. Okay, then I'm using this. See, this will be the answer that I will be returning. Okay, if you see here, this is going to be the answer that I'm going to return. Okay, this is the one. As simple as that. Okay, and there is a else condition also. See, if none of the results match, you have to return -1. Okay, that also will have to take care, right? So I'm initializing this with float of infinite. Okay, but in my Java solution, you will get to see that. See, you can also keep it just as n+1. Okay, you can just keep it as n+1 also. That is also fine. Okay, if you see here, I'm just keeping it as n+1. That is also fine. But yeah, since here in Python we have the scope of going for the infinite, so I'm keeping it as an infinite value. But yeah, it is not needed. Okay, it is not needed because we are going to use the min operation. That's why I've kept a maximum value. As simple as that, right? At last, I will be checking that also. That if it is still infinite, okay, then we'll have to return -1. Okay, if yeah, as simple as that. If it is not infinite only, then I will return the original value, right? So that is the first part. Now coming to the bitmap. Okay, what is the bitmap? It's going to do, see, it will have 30 elements. Why 30? I've already explained you that I am going to take 30 because all the values in this particular, okay, based on the constraint, 30 bits will be enough to record all the values. Okay, that is the basic idea here, right? So I'm going to take a bit, okay, bitmap of the subarray is equal to a array of integer which is having 30 elements. Okay, initially all of them will be 0. First thing. Now, what is this? So idea here is, see, whenever I am moving, see, I have a window, right? In that window, I am going to record the bits of each element using this particular thing. Okay, that is, for example, let us say a bit. Okay, bitmap of subarray of I. What it means, it will tell me inside that particular window how many elements I have that I will set. Okay, it will give me a count of that. Okay, so what is that bitmap of subarray of I will be how many elements inside the current window have that particular bit set. Okay, let us say it can be 5 10. So how many ever it will be, it will tell me how many elements in my current window have that particular bit as 1. Okay, that is the basic idea of that. So that's what I'm going to record here. Okay, initially everything will be 0. That's something that I want to tell you. Okay, so based on as I move in my window, these things will be changing. Okay, let's say I added a new element, I have to add those bits to this. Okay, as simple as that. If I removed an element from my current window, I have to remove that also. Okay, so for that I will be using this particular function. What is this function doing? Remember one thing, the difference that you will see in Python Java code is here. Okay, in Python basically we can declare the function inside the function itself. Okay, so this is the main function. Inside that itself I'm declaring another function. Okay, in Java you cannot do like that. Okay, you have to declare it outside the current function. Okay, that is, it has to be another function of the class, not inside the current function. Okay, so what I'm doing here basically, so whenever I'm adding or removing element, this particular function will be called. What it will do, it will take two things. Okay, it will take the e. Okay, it will take the e, that is the element that I'm going to insert new, or the element that I'm going to remove. Okay, what is value? Value will be either zero, it will be either one or minus one. Why like that? So when I'm going to insert e, the value will be one. When I'm going to remove e, the value will be minus one. Okay, the value will be minus one in that case. Okay, you will get to know why I'm doing that. But see here, non-local you have to always call if some you are referring something which is declared outside this function. Okay, that is second thing. Now why I'm going till 30, because I'm going to consider only the 30 bits. Okay, every see all the inputs that I'm going to get elements within 30 bits, everything will be able to, we will be able to record. Okay, based on our calculation. So I am going to stick to this calculation. Okay, as simple as that. So where we are seeing 30, this is because of that reason. Okay, so what I'm going to do, this thing you will be able to understand if you have seen my previous videos. Okay, 3-4 days videos previously, if you see, you will get to know this, because we are frequently doing this. Okay, so what is this? Basically this is a left shift operator. Okay, I am left shifting the one by the how many times, by I times. Okay, why I am doing that? See, the idea here is I want to see whether the ith bit, okay, in this particular element is set or not. What is mean by set or not? Whether the ith element in this particular element e is one or not. That is what I'm trying to check. Okay, so what I have to do, I have to take e. Okay, I have to do an AND of that with a number whose ith bit is set. Okay, this is a number whose ith bit is set. What is that? How I am getting that? I am left shifting one by I n times. Okay, by I times. That means in the number that I'm going to get, the ith bit will be one, rest all bit will be zero. Okay, I'm doing AND operation here, right? I'm doing AND operation. What is AND operation? If you see here, basically only the result will be one only if both the bits are set. Okay, if you see here, result will be one only if all the bits are set. Even if one of the bit is not set, it will return zero. Okay, so it will be greater than zero only if the e, that is the element that I'm going to insert or remove, has the particular bit as one. Okay, otherwise the result will be less than zero. Okay, remember it has place values also. That's why I'm writing equal to zero. You should not add equal to one like that. Okay, that will not happen, because see, it has place values also. Even if it is one, you will get answer as 8 or 16 or 32 something like that, because it has place value also. Remember that. Okay, so e, and I'm doing AND operation with an integer whose ith bit is set. Okay, so the AND of this will tell me it will be either a zero or a non-zero. Okay, if it is zero, that means the ith bit in e is not set, it is zero. Okay, if it is this particular thing is greater than zero, that means the ith bit in e is set. Okay, and it is one. So if it is set, what I have to do here, I have to do bit array, that is bit map of subarray of I plus equal to one. Okay, this will be one in that case. Okay, remember value will be either one or minus one. Why I'm taking one? See, one is when I'm expanding the window, I'm adding a new element. Okay, for that I have to add one to wherever the ith bit is set in e. Okay, as simple as that. Let us say I'm going to remove element. In that case, what I have to do, wherever the bit was set in E, I have to do a minus one in all those places. Okay, so that time value will be minus one here. Okay, as simple as that. So this function will be called whenever we are adding a new element to our window, or we are removing sub element from our window. What is the window? Window is, I'm calling it as a sub array. Okay, you can call it the way you want, but I'm calling it as a sub array. Next, what I'm doing next is evaluate the sub array. Okay, now currently let us say I want to evaluate, like within my window, like what all elements I have, what is the result of their or operation, whether they're greater than or equal to k or not. Okay, for that reason I will be using this particular function. What this function will do basically, see, again same thing, whenever you are declaring something, that is you are using something that is not declared inside the function, you have to use a non-local operator, and you have to define that. Okay, that's what I'm doing it here. Okay, next, what I'm doing, I'm keeping result equal to zero. See, the idea here is, let us say in my bitmap array, okay, I have like how many elements are going to have that particular bit set. Okay, but I don't need the exact values. What I will check, whether the particular element is zero or not. Okay, if it is non-zero, whatever the number is, that is not going to matter to me, because I will be just using its place value. Okay, I will be multiplying 2 to that. Okay, I'm just going to use its place value. That is, I need only the XOR, that is the OR result. Okay, just remember that I just need the OR result of that. So what I will be doing, I will be going till 30. Okay, for each value, that is bitmap of subarray of I. If it is not zero, that means at least one element in that particular window, at least one element has this bit set. Okay, so in the result also this bit will be set. So what I have to do, I have to do 2 raised to power I. Okay, I is its place value. Remember that I is its place value. If I is 0, that is in the first place, the value will be 1. 2 power 0 is 1. If it is, let us say, in the second place, the value will be 2 square, which is 4. Okay, similarly I have to keep adding them to the I. Okay, in Python, see, this double star basically is raised to power. Okay, it is 2 raised to the power I. Okay, fine. Then this value is set. result, I'm going to add everything to the result, okay, for all 30 bits, and finally I'm going to return result. Okay, here I did not return anything. If you see here in this, I did not return anything. Here I will be returning the result. Okay, that is the difference here. Now I'm going to start the sliding window approach. Okay, till now we were just defining the functions and defining the arrays to maintain the answers. Okay, but now the real answer starts. Okay, let me expand this, and yeah, let me zoom in further. Yeah, now the real answer will start. What I'm going to do, see, while subarray end is less than -1, okay, and -1, why like such a condition? First of all, if you see the last value that is going to come, okay, see, while I'm entering, I'm doing a +1. Okay, so the idea here is to does not cross, so to ensure that the limit is not crossed, okay, I'm keeping this as less than n-1. Okay, the what is the last value that is going to enter? N-2 will be the last value that is going to enter. If I do a +1 in that, it will be n-1, and which is the last value, right? So that is the basic idea. So based on your these conditions, you have to basically declare what you're using here. Okay, so what is the idea of window expansion? What it means, I'm going to increase the end of the window, that is toward the end of the window I'm going to increase. For example, let us say I the current window is like this. What will happen next? It will be increased, that is 1 2 3, and 4 will also be included. That is called window expansion. Okay, that is the end of the window is going to expand. Okay, sub array end is equal to sub array end plus 1. Okay, next what I'm going to do, since I have now increased the window, the element that I have newly included, I have to catch its bit. Okay, I have to now take its bit and update in my this particular array. Okay, bit map of subarray, here also I have to add that. Okay, so I will be calling this function. Okay, add remove element to subarray, then here I will be passing 1. Okay, that means I'm going to add this element. Okay, nums of subarray end. Okay, what is the new subarray end? That element I'm going to take and I'm going to pass 1. So what this function will do, it will go here and it will like find out within that new element which all bits are set. Okay, which all bits are set for its corresponding index, I'm going to do +1 here. Okay, that it will tell me the ith bit is set for this element. Okay, as simple as that. This value is 1 in this case, right? So this is done now. Okay, I have added all the bits of that to my this particular array. Okay, this particular array, yeah, bitmap of subarray. Next what I'm going to do, so this while will continue when there are two conditions met. Okay, first thing is evaluate subarray of evaluate subarray, or okay, I'm going to do the operation of all the existing elements in the subarray, and if the result is greater than equal to k, only then I will enter this loop. Okay, only then I will enter the loop and start contracting the window. Remember, if this operation is not true, I will not contract the window. Okay, what is the next thing? This loop will run till the subarray start is less than or equal to subarray end. Remember, even a single element is actually a window, right? A window can be of a single element also. For that reason, I've included the equal to condition also. Subarray less than or equal to subarray end. Okay. So what this contract operation? Remember, this will only function when we are having s or result of greater than or equal to k. Okay. So what is this or? This contraction? See, let us say this is our window, right? Currently the window is 1 2 and 3. Okay, what I will do now, see, previously expansion means at the end of the window will expand. Okay, 1 2 3 and then 1 2 3 4. Okay, this is the window expansion. What is window contraction? Okay, let us say this is our window. What I will take, I will remove the start. Okay, now I will only consider 2 and 3. Okay, that is the window contraction. Okay, so if you see, the window will become 2 and 3 now. Okay, previously it was 1 2 3. Okay, what will happen now? It will become 2 and 3. Now I will check whether I'm still getting XOR result, that is or result of greater than or equal to k or not. Okay, that's why this value is there. Okay, so what I'm doing, I'm contracting the window. Before doing that, I'm recording the answer. Okay, since for the current window also this result is true, so this is also a probable answer. So I'm just doing this operation. What is this operation doing? Okay, minimum possible length of subarray is equal to the previous value comma the current window size. Okay, what is the current window size? Subarray end minus subarray start plus 1. Okay, why like that? Remember, a single element also can be a window, right? When we have a single element in the window, what will happen? Subarray end and subarray start are going to be same. So if you subtract them, they will become 0. That's why I have to add this additional 1. Okay, that's why I'm adding this additional 1. If you see here, right, this is the 1. So I'm taking the minimum of the previous value, the current window's length. Okay, this I'm saving. Okay, this saving part is done. Next I will start moving my this thing. Okay, so what I have to do now, this start element, okay, I have to remove now from my window. So I'm calling this function. Remember, this is the same function which I called here. Okay, but here I passed a value of 1. Here I will be passing a value of -1. Okay, so add remove element to subarray, I will be passing the starting element and a value of -1. What this will do, whichever bit is set in this particular element, right, whichever bit is set in this particular element, I am going to remove it from my this particular array. Okay, bit map of subarray, here I'm going to remove it. Okay, so it will find out which all bits is set in this particular element e. Okay, and those bits will be removed. Why I'm removing? So this value is going to be -1 now. Okay, so those places I'm doing a -1. Okay, that is whichever bits were set for this element, now I'm doing a -1 in that to remove it from my this particular map. Okay, bit map of subarray, right? That is done now. Next, what I have to do, since that element is not removed, I will be doing a sub array start of plus equal to 1. Okay, that is, I am moving the window. Okay, previously it was 1 2 3, now it will be 2 and 3, right? That is now moved. Okay, since it is inside a while loop, if this loop completes, it will again check these conditions. What is the condition? It will evaluate after moving the start also whether I'm still getting a, a or result of greater than equal to k. Okay, if it is still true, then yeah, if this condition also we checked, if this is also true, then we will continue further. Okay, once we come out of this loop, that means either this thing got expanded. Okay, that is, either it failed because of this condition that we tried everything. Okay, result was greater than equal to k, but we failed in this condition. That is, now there is nothing left in my window. That means I will come out of this. Okay, that's the first thing. Second thing is, let us say I had a window, there were elements in my window, but the result is not no more greater than equal to k, the or result is no more greater than equal to k. Then also I will come out of this while loop, right? Once I come out of this while loop, this particular loop will still continue, right? I will be still expanding. So this is the contraction part. Once contraction part is over, that is, we failed at least this condition or this condition. What we will do next, we will again start expanding the window. That is, we will start expanding the end of the window. Okay, here we were contracting the start of the window. Here if you see, we are doing +1, but here we'll be expanding the window. Okay, I will add a new element and this process will keep continuing. Okay, once I come out of this loop, basically, what I will check, whether the minimum possible length of subarray is changed or not. See, I started with this value, right? If you see here, I started with this particular value. Okay, if this value is unchanged, that means nothing happened inside this. Okay, inside this, none of the values were suitable. Okay, that's none of the windows satisfy this condition. Okay, that means there is no possible answer to my question. And see, this is what it's saying, right? Return -1 if no special subarray exists. Okay, that is what I'm going to do. I'm going to return -1 in that case. Okay, if this condition is not true, then I will be returning the same value. Okay, the same value. Okay, let me quickly run this and show you. Okay, as you can see, it's clearing all the test cases, and I've added some additional test cases. If you see here, this particular thing, it has around 9 zeros. Okay, that's why based on the condition here, I'm adding a value like this to ensure that whether my solution works for this or not. Okay, similar, I gave a key also, which is a bigger one. Okay, maybe you can also do the same to understand whether your solution really works or not before submitting it. So this was the end of the Python solution. Okay. Here, what you can get to learn is, see, you will have to learn the left part. Okay, how it works. You will have to learn that. Okay. Next thing is, I'm using float of infinite. If you are not knowing something like this, you can use it. But yeah, in this question, you can also use n+1 as the starting value of this. Okay, I've done the same in Java. So you could have also done that. You can learn about non-local thing. Okay. That is another thing that you can learn. You can learn about the star operators to do a power off without using any inbuilt functions. That is another thing. And you can also learn about this sliding approach and how it works. Okay, how the window is expanded, how the window is contracted. Okay, because if you are getting this in interview, you will have to basically write in a paper and you will have to show how the window works. Okay, that is another thing that you can learn from this. Okay, and yeah, one more thing, important thing is, yeah, you should always do this kind of calculation before starting the question. Okay, this is another thing that you can learn from this particular solution. Now I am jumping to Java solution. Okay, from here everything I will discuss with will be Java. Okay, so in the Java solution, if you see, as I mentioned, in Java, you cannot have a function inside the same function, right? So for that reason, I'm going to add some extra functions here. Okay. So this is the first function. This is the second function. And if you see here, I've added another data member. Okay. Because see, if I have to access this value from all the functions, I have to keep it, as a member of the class instead of keeping it as a separate, member inside one of the functions. What I'm doing, I'm keeping it as a member of the class so that I can access it from any of the functions, right? So I'm declaring this as a private function. I'm declaring as a private function with a return type int. Okay, so this is the same like I showed in the Python video. So what I'm doing here, whenever I'm going to add element to my window, I will be calling this function. Okay, for adding purpose, what I will do, I will pass the value as 1. Okay, this particular element, and that's value will be 1 when I'm going to add element to my window. So what will it will do? It will learn from 0. That is, see, I'm using 30 bits. Okay, the same thing I explained in the Python solution also, that if you see, this calculation shows that for the 10 power 9 values, that is the range here, for a value of approximately 10 power 9, we need only 30 bits. Okay, so that's why in the Python as well as in the Java solution, I'm going to use the 30 bits only. Okay, so it will run for 30 bits. What it will do, see, the element that I'm going to get, okay, this, I have to record all the bits that are set in this to my array. Okay, which this particular array I have to record that. Okay, so what I'm doing, I'm doing AND operation of the element given to me with a number whose only bit set is I. That is, only ith bit is set for this number. Okay, so I'm getting that. I'm doing a left shift for 1. Okay, I'm doing left shift of 1 by I times. Okay, so I'm getting a number whose only ith bit is set. Okay, I'm doing AND operation on that. So if you have learned about AND operation, what it means, only if both the bits are set, only then the resultant bit will be 1. Okay, so that logic I'm going to use. Okay, if let us say the ith bit is set in this also, and obviously the ith bit will be set in this, so we are going to get a result which is greater than 1. Okay, in greater than 0 in this case. Okay, otherwise the result will be 0. And you could have asked me why I'm not doing is equal to 1 in this case. Remember, it has place values also. Okay, so that is, if let us say the 1 is in let us say fifth or sixth position, so it will be 2 power 6. Okay, so the value will not be 1 in that case. Okay, it will be 2 power 6. So see, there are the position values also, so always it's better to check greater than 0. Okay, instead of checking is equal to something, right? Always check greater than 0 or is equal to 0. Only two things you should check. Okay, so if in this case, if it is set, the value will be greater than 0 of this. Okay, AND operation. So in that case, what I'm going to do, I'm doing a bit map subarray of that position plus equal to value will be 1 in this case. Okay, this will be the case when I'm going to add a value, okay, in my particular window. Let us say I'm going to subtract a value, that is I'm going to remove a value from index. What I've been from a window, what I should do, this value will be -1 in that case. Okay, so if you see, what I see, the objective here is, when I'm removing a particular value from the window, what I have to do, take the window as it is. Okay, sorry, yeah, take the this particular array as it is. So whichever bits are set for the element that I'm going to remove, so come here and remove those bits here, that is, come to those indexes and do a subtract of 1. Okay, as simple as that. Now what I'm going to do, same, I'm creating another function. This will be for evaluating the or of the current window elements. Okay, so what I'm going to do, just see, the see, or operation is what, basically, okay, whichever bits are set, you have to just take those bits. Okay, whichever bits are set, and you have to evaluate. Evaluation basically means what is the final answer that I'm going to get. So this is the same as how to, if you have given a binary number, how to get the original number back. That is what I'm going to do here. Okay, so you have to just use math.power of power, that is the power, that is 2 raised to power I. Okay, based on the place value of that, you have to do a 2 power that. Okay, and we are going to get the results back here. Okay, as simple as that. I've already explained this in detail in my Python, so I'm not doing a much detail explanation here. Okay, now coming back to the solution. N will be the nums length. Okay, these are two variables I'm going to use to design my window. Okay, the start of the window and the end of the window. Okay, that is the thing. Next, okay, minimum possible element of, remember, n plus 1 is never going to be a solution. Okay, answer can never be n plus 1, because see, I'm going to return a subarray length, right? Subarray length cannot be more than the current array length, right? So that's why I'm keeping it as the initial value. At last I'll be checking whether it is like this. If it is like this, that means no answer is possible. Okay, only if it is not equal to this, that means some answer is there and I have to return that. Okay, this is going to be edge case here. Okay, if you see here, this is the edge case. So now let us learn about how we are doing it. Okay, here I am initializing the bitmap of subarray. So bitmap subarray of I will be basically how many elements in my current window are having that particular bit as set. Okay, that is the basic idea. Next, what I'm going to do, this from here the sliding approach starts. So what I'm going to do, expand the window. Okay, expanding the window means expanding the end of the window. Okay, subwhere end plus equal to 1. Okay, that means a new element is now inserted. So I will record its bits in my this particular array. Okay, bitmap of subwhere, I'm going to record those bits using this particular function. So if you see this function, what I'm going to do, basically I will go through all the bits of that particular element that is going to be inserted, and those places I will be doing a +1. Okay, if you see here, just a second, if you see here, I am passing a value of, yeah, 1. Okay, in this case I'm passing a value of 1. Okay, that is there. Then what I will check, this is the while loop. Okay, this is the while loop. Inside the while loop, what I'm going to check here, see, first of all I will evaluate whether the elements in my current window are having a or a result of greater than equal to k or not. Okay, if it is so, only then this loop will be start. Okay, only then this will start, and this is going to be a condition through which the loop can be stopped. Okay, that is as simple as that. That is, even it will see, it will basically do is, like, even if my current window has a single element, this will allow the loop to run. Okay, so mostly the stopping word will be this: whenever the current window has elements for which it is no more equal to k, then the window contraction will stop for that. Okay, then again the expansion phase will start. So what is the contraction phase? First of all, I will record the result. See, for the current window also, because this condition is true for the current window also, first I will record the results. Okay, that's minimum possible length of subarray is equal to math.min of the previous value, comma, the length of the current window. Okay, what is the length of the current window? Subarray end minus subarray start plus 1. Okay, next I'm going to remove the element, okay, which is at the start. Okay, nums of subarray start comma -1. Why I'm doing, see, this -1 basically ensures that I will be subtracting those values. Okay, whichever value I added while adding that element, now I will be removing those values, as simple as that. Okay, No, fine. Then I'm doing a Subarray start of +1. Okay, this is the window contraction phase. Then that means my window has changed now. So I will go back and check these conditions. Okay, this condition will ensure that there is at least one element left in my window, and this condition will ensure that the OR result of the current window elements is greater than or equal to k. If this is not true, I will break this for loop and I will come out of it, and again the expansion phase will start. Okay, as simple as that. So once I come out of this follow-up, that means when I explode everything, okay, whenever the k we are getting the result of OR operation greater than or equal to k, we are trying to reduce the elements. Whenever we are not getting that, we are trying to expand the elements to get the result. So this is what will happen, right? Once we come out of this, I will doing this check. Okay, if my this thing is not equal to -1, because it started with -1. Okay, it started with that. Yeah, this is where it is. It started with that. So if it is not -1, that means something has changed. That change I will be returning. Okay, if it is not true, then I will be returning -1. That there is not no possibility of getting a result like that. So let me quickly run this and show you. As you can see, this is clearing all the test cases. So yeah, friend, that was all for today. This was a really large video, I guess, but yeah, I explained everything to you, every possible thing. Okay, in the Java solution, basically, there is nothing new to learn. See, everything that is whatever I'm using, I covered in the previous videos also. So I don't think there is anything extra to learn here. Okay, yeah, that is all for today. Yeah, like in interview, basically you will be asked this question also: why you are declaring the private, why can't you declare it as a public? So those questions also be asked. So be ready for those things also. Okay, and why you are declaring it inside the class and not inside a private function? These things will be asked. So you have to know a solution for that also. Okay? And obviously remember which library to include. Okay, since I'm using the this particular function math.power and this particular thing. Okay, math.min. So I'm including the math library which is inside the lang. Okay, lang package. So yeah, that was all for today. I hope you like my efforts. You, at least if it is benefiting in some way for you, please do subscribe to my channel. It really gives a lot of motivation to continue this journey further. Right? It takes lots of efforts to build this kind of videos. After doing a lot of research, I am getting the most optimal solution for you. Okay, if you get at least something extra to learn, please do subscribe to my channel. It really gives a lot of motivation. See you tomorrow. Thanks a lot.